Lung volumes and capacities. These can be recorded on a spirometer, and you've probably seen it. It's a line which looks like a wave. It starts quite small, goes all the way up, all the way down, and then returns back to a tidal volume. Now, tidal volume is the first volume that we're going to look at, and this is basically the air or the breath that you take when you're living. Now, when you're resting, it's going to be a lot smaller, but then when you're exercising, it's going to be far larger. But it's your regular intake of in and out. So when resting, it's far smaller, and this increases when we start to exercise. Now, above the tidal volume, so after a regular breath in, we have what's known as the inspiratory reserve volume. It's the air that you can call upon after a regular inspiration. So at rest, this is quite a substantial volume because we've taken one normal breath in, and then we've got everything beyond that up to our total capacity to breathe in or to breathe in from. The opposite of that is the expiratory reserve volume. Following a regular breath out, it's all of the air that remains inside of your lungs all the way down to the residual volume, and I'll go over that in a second. So tidal volume is your regular breathing in and out. Inspiratory reserve volume is the volume of air above your regular inspiration, and expiratory reserve volume is the volume of air below your regular expiration. Now, residual volume is the volume of air that will remain in your lungs or reside in your lungs despite how hard you try to expire. So you can contract your expiratory muscles as much as you like, but that air is never going to be pushed out. The only way it could be is if there's a force actually being applied to your cavity and it's effectively being crushed, and that's a collapsed lung or a crushed lung. So residual volume remains there. Now, if we combine the tidal volumes and the reserve volume, we actually have something called an inspiratory capacity. So if we breathe in from our tidal volume and then add this to our inspiratory reserve volume, the total number there is known as our inspiratory capacity. And a capacity is when we combine two or more volumes into one total. So tidal volume in plus inspiratory reserve volume is our inspiratory capacity. And the same goes for expiratory capacity. If we add the volume of air that we breathe out regularly and add that to the expiratory reserve volume, that will give us the expiratory capacity. Now, the last two are total capacity, which is residual volume, the air that will always be in your lungs, add everything else, or the maximum amount of air that you can actually breathe in. So the most that we can actually inflate our lungs to is known as our total capacity. The last one is vital capacity. This is the workable amount of air that we can breathe in and breathe out at our maximum effort. So all the way from the top, all the way down to our residual volume. We're not counting the air which will reside in our lungs regardless of breathing. It's just from above that all the way up to our total capacity. So tidal volume, inspiratory reserve volume, expiratory reserve volume, and residual volume. We then have inspiratory capacity. We then have expiratory capacity. We have vital capacity, which is our workable amount, and then we have total capacity. And that's the lung volumes and capacities.